Fire accidents are one of the most dangerous and unpredictable emergencies, often putting human lives at a great risk. To reduce this risk and improve response time, we present our project, the firefighting robo using Arduino. This project has been developed by Group 1. Hands involved are mentioned on the screen. This robot is designed to automatically detect fire, navigate towards the source, and extinguish it using a water based mechanism without direct human intervention. By integrating sensors, actuators, and an embedded control system, our project demonstrates how robotic can play a crucial role in safety and disaster management. In this video, we will walk through the design, working, and the real-time demonstration of our firefighting robo. I now hand over it to Subhankar for the presentation.
Hello everyone, I am Subhankar Pandit. Today I am presenting our project titled Firefighting Robot using Arduino. This project focuses on developing an autonomous robotic system capable of detecting and extinguishing fire without human intervention, thereby improving safety and response efficiency. Let's see the challenges. Traditional firefighting methods expose human personnel to serious risks such as toxic gases, high temperatures, poor visibility, and structural collapse. In industrial and enclosed environments, delayed response time can further increase damage. Hence, there is a strong need for autonomous and automated systems that can operate safely in such hazardous conditions. Let's see our solution. To overcome these challenges, we designed an autonomous firefighting robot. Flame sensors monitor the environment using infrared radiation. The Arduino Uno acts as the central controller, processing sensor data and directing robot movement. Once fire is detected, the water pump is automatically activated to extinguish the flame. Proceeding with the project objectives, the primary objective of these projects are to design a low-cost and efficient autonomous firefighting system, to integrate sensors, robotics, and embedded systems for real-time operation, to minimize human involvement in hazardous fire scenarios, and finally to achieve fully autonomous fire detection and suppression. Let's look into the system architecture. The system architecture is divided into three layers. First one consists of the input, consisting of flame sensor placed at the center to detect the fire, and the second one is the control layer, uses Arduino Uno to analyze sensor data and make decisions. The third one is the output layer, includes motor driver that directs the movement using the DC motors and the water pump to extinguish the fire. Proceeding with the circuit diagram, this slide illustrates the complete circuit integration. Arduino Uno is interfaced with the motor driver, which controls four DC motors and the water pump. The system is powered by three 2200 mAh battery, ensuring portability and independent operation. Proceeding with the key components, the major components include Arduino Uno with Atmega 328P microcontroller as the control unit, infrared flame sensor for fire detection, a motor driver to control speed and direction of motors, and a DC motor water pump to spray water for fire suppression. Proceeding with the research foundation. Our work is supported by previous research in this domain. Earlier studies demonstrated Arduino-based fire detection systems. Recent research focused on autonomous navigation, IoT integration, and cost-effective designs. These studies guided the design and implementation of our system. Let's see into impact and future vision. Control. Currently, the robot successfully demonstrates autonomous fire detection and extinguishing using low-cost components. In future, the system can be enhanced by adding IoT for remote monitoring, camera modules for visual feedback, and also we can use AI-based algorithms for intelligent decision making and navigation. Hence, to conclude, this project demonstrates the effective integration of the embedded systems, sensors, and robotics to create a safe, efficient, and affordable firefighting solution. With future enhancements, this system can be scaled for industrial and domestic fire safety applications. Thank you. Now we will proceed with the component discussion of the prototype.
Hello, this is Sekhar Samal.
And I am Prasad Mishra. We are going to explain the component used and the working principle of our project.
So this is Arduino Uno. This is brain of our project. It receives signals from sensor and control all the component. Then this is flame sensor. It detects the fire and sends signal to the Arduino. Then this is servo motor. It rotates the nozzle towards the fire so the water can spread correctly. And this is water container. It stores the water used to extinguish the fire. Then this is water pump. It pushes the water from the container to the nozzle. Then this is water pipe. It carries the water from the container to the nozzle. Then there is battery. It supplies the power to Arduino motor and pump. Then here is the converter. It reduces the voltage and protect the Arduino from high power. Then this is the Bluetooth module. It allows to control the robot wirelessly when it needed. Then here we can see the DC motors. Here we can see DC motor. It helps to move the robot forward, backward, and turn. Then inside it, here you can see L298 and motor driver. It controls the speed and direction of the motor. And here there are wheels. It allows the robot to move smoothly on the floor.
As my friend has explained the component used in the project, so I am going to explain the working principle of this project. So the flame sensor scans the surrounding and detects the air produced by a fire. When then a flame is detected, sensor signal to the Arduino Uno. The Arduino acts as the brain of the system. After receiving the signal, it immediately stops the motor. Then it rotates the servo motor so that the nozzle is pointed towards the fire. The water is stored in the water container supplied through the pipe. The Arduino turns on the water pump. The water is sprayed directly to the flame. The robot keeps spraying until the fire is extinguished. In this way, the robot is able to detect, aim, and extinguish small fire automatically without human involvement.
Hello, I am Soumik Dalei. I am going to explain the code. So at first we see we are including two libraries, servo and software serial. So servo library is used to control the servo motor, and the software serial library is used to handle Bluetooth communication on custom pins. So in this line, we are connecting Bluetooth serial using pins 2 and 3, allowing the robot to receive movement commands wirelessly. Next, these pins control the motor driver. By changing their high and low values, the robot can move forward, backward, or turn. Next, we are assigning pins to flame sensor pin, servo motor, and water pump. Then we are declaring a servo object for nozzle control. The command variable stores input, Bluetooth input, and the autonomous mode decides whether the robot runs automatically or manually. And here is the setup function. So the setup function runs once when the system starts. All motor and all motor and pump pins are set as outputs, and the flame sensor is set as uh, input. Okay, so the servo motor is centered at 90 degrees. Bluetooth and serial communication are initialized, and the pump is kept off initially for the safety. So here is the function to move the robot forward, or here is the function to move the robot backward, and here is the function is to for robot to turn left, and here is the function to turn robot right. This function stops all motor movement by setting every motor pin to low. So here is the when a fire is detected, the robot first stops and then uh, turns on the water pump. Then the servo motors rotates the nozzle from left to right to spray water over the fire. The nozzle then moves back to cover the area again for better fire extinguishing. Finally, the pump is turned off and the servo is reset to the center position. So, in the loop function, the robot first checks for Bluetooth commands. If the command is A, then autonomous mode is enabled. If the enabled, otherwise manual mode is selected. The flame sensor is read continuously. A low value indicates that the fire is detected. If the fire is detected, the robot immediately stops all other actions and starts extinguishing the fire. Yeah, as you can see, the function is there. So here in autonomous mode, the robot moves forward automatically. In manual mode, it depends on the Bluetooth commands. At the end, a small delay is added to ensure smooth and stable execution. Now we are moving forward towards the demonstration of the project.
My name is Sonal Mishra. The firefighting robot can also be operated manually using Bluetooth control through a mobile application. The mobile phone sends directional commands via Bluetooth to the Arduino controller. Based on the received commands, the robot moves forward, backward, left, or right using DC motors. This manual control mode allows precise navigation towards the fire source before activating the extinguishing mechanism. Bluetooth based locomotion provides flexibility, reliability, and safe remote operation in controlled environments.
Hello all, this is Prasad Mishra. To demonstrate the application of our firefighting robot, a matchstick flame is brought near the sensing area. The flame sensor immediately detects the presence of fire and sends a signal to the Arduino controller. In response, the robot activates the servo mechanism, aligning the water pipe towards the flame source. The water pump is then triggered, spraying water precisely to extinguish the fire. This demonstrates fast, accurate, and automated fire response in a controlled environment.